Hello, I'm a member of Mass VIP of Po항제철고 High School. Let's start the Latin square presentation. Let me begin the explanation of Latin square. The table of contents include the concept of magic square, the origin of magic square and Latin square, and last, the solution of Latin square. First is the concept of Latin square. The n or the Latin square means that the natural number from 1 to squared n are written in the n multiple n matrix, n rows and n columns repeatedly, so that the sum of each column, row, and diagonal is all the same. In Korean, the Latin square is called 라틴방진. Ma means the mysterious magic, bang means square, and jin means to lay out. So the Latin square means that a combination of mysterious numbers is arranged in a square. Second is the origin of Latin square. According to a Chinese legend, a large turtle came out while the net bridge was under construction in the southern Yellow River tributary in order to prevent flood damage on the Hwanghae River. Counting the dots on the turtle's neck with symbols is called naksa, meaning the heavens writing obtained from the waterfall. This naksa is called bangjin because it is listed as a square with numbers. Bang means square and jin means camp. The first naksa made in China is a certain magic square with 5 natural numbers from 1 to 9 in the middle, arranged in 9 spaces without overlapping or missing, and the sum of the numbers horizontally, vertically, and diagonally is 15. At this time, people believed that naksa implies the secrets and truths of the world. Due to the uniqueness of the agreement of numbers, it has been recognized as an array of numbers representing the truth of the universe.
Third, let's look at the Latin square. The nth Latin square is a type of magic square that uses n numbers, letters, or patterns or colors so that they are arranged without overlap in each row or column. That is, there should be no overlapping patterns on the horizontal verticals. Each row and each column are sequences. Stoke, which we commonly use, is an example of the ninth Latin square. The name Latin square comes from mathematician Euler's use of the Latin alphabet instead of numbers. The following is a picture of a third Latin square with color and a ninth Latin square stoke. Next, let's look at the vertical Latin square. The square made by combining two Latin squares that are vertical to each other. That the two n-ordered Latin squares are vertical means that all possible ordered pairs of n squares are made. The first person in the world to make the ninth vertical Latin square is 최석정 of the Joseon dynasty. 최석정 introduced this in his book 구수략 under the name of 구구 모수변 궁양도. Then let's look at how these magic squares and Latin squares are used. It is currently applied in many areas, including researching agriculture productivity, building design application, psychological testing, biological, pharmacological, industrial experimental planning, and design application. Especially, it is applied to modern telecommunication technology, and the ninth vertical Latin square was used for semiconductor chips. The core technology of semiconductor chips is to send signals quickly and without overlapping, which is to use the technology of magic square. Let me look into it with more detailed examples. In the early 20th century, Ronald Fisher used magic square to investigate the productivity of agriculture, using the fourth vertical Latin square to find the best pair of wheat and fertilizers to grow. Latin square is used to design clinical experiments of new drugs with similar principles. We can effectively identify side effects or effects by utilizing Latin square in the design of clinical experiments of new drugs. The following is an example of using the fifth Latin square to efficiently conduct clinical experiments of 5 types of experiments. The n-order Latin square is an arrangement of natural numbers from 1 to n in an n shape so that the same number does not come in any row or column. Considering the characteristics of the Latin square can be created not only by numbers but also by shapes and pictures. Now let's try to solve this in Latin square. If you look at this solved Latin square, you can see that neither row nor column has the same shape. This Latin dust proof is a combination of 3-3 and 4-4 and 5-5 Latin square, and the number of jewelry elements that make up each Latin square varies depending on the type, so you should be careful about this. Now we've solved the Latin square. If the number of Latin square elements is different, it can be solved the fastest when solving Latin square which has the largest number of elements first. Now let's make the third magic square. First, draw a diagonal line passing through the upper right room and draw the total of 3 diagonals one by one. Write the number from 1 to 9 on the drawn diagonal. Move the number of edges, such as 1, 9, 7, 3, to the inside of the opposite side. Finally, we are going to make a 3-3 form of magic square, and we can see that the sum of elements in every row and column converges to 15. When creating a fourth magic square, arrange the given number in 4 frames in order from 1 to 16. Draw diagonals on both sides and change positions between the inner numbers and outer numbers of each diagonal. Here, we change the positions of 6 and 11, 1 and 16, 10 and 7, 13 and 4. This change of place creates a fourth magic square in which the sum of all rows and columns of elements converges to 34.